In the first sum, we are to prove that triangle PDA and triangle SCD are congruent. The first thing to do is to decide which rule to use. We look at the diagram to see that we are given two sides and one angle in between the sides. Therefore, we choose this rule which suits the condition, two sides given and the angle between the two sides. This rule is side angle side. The letters must be arranged according to corresponding points. Therefore, we can pick out the equal sides and equal angles from the arrangement. PD equals to SC. And this is a given side. Similarly, AP is equal to DS. And again, this is a given side. Finally, the angle, which is APD. Looking at the arrangement, APD is equal to DSC. And this is also given. Thus, we complete the proof. In the second sum, we are given PQRS, which is a parallelogram. That means we have parallel lines, which means that we can identify alternate angles which are equal, such as this angle and these two angles. Thus, we can notice that we have a triangle with two angles given. And looking down the line, the rule to use is either one of this rule, angle, angle, side, or angle, side, angle. Now, we also notice that both triangles share the same side, QS, and this side is between the angles. Thus, we will choose this rule, which is angle, side, angle. We first write the arrangement, which is triangle PQS, which is congruent to the angle at Q is equal to the angle at S. Therefore, Q corresponds to S and S corresponds to Q. And P will therefore correspond to R. And the rule we use is angle, side, angle. The first angle is PQS. PQS is equal to RSQ. And they are alternate angles. And the parallel lines are PQ parallel to RS. Next angle is the angle PSQ. And angle PSQ is equal to RQS. And once again, they are alternate angles, but this time the parallel lines are PS parallel to QR. Finally, we have a common side, which is QS is a common side. So we have two angles and a common side. Angle, side, angle. This completes the proof. In the third sum, we are to prove that triangle PTQ and triangle STR are congruent. In this case, it is very obvious that only three sides are known and there are no angles. Thus, it is obvious that we choose this rule, side, side, side. Therefore, triangle PTQ is congruent to triangle STR, and the rule is side, side, side. And it is very easy to pick out the common sides. PT equals ST is given. Similarly, TQ equals TR. And finally, PQ equals SR. And this completes the proof. In the last sum, we are to prove that triangle ABE and triangle DCE are congruent. As you can see, we have only one known side. Therefore, we need more information. Since these two sides are equal, therefore, we have an isosceles triangle, which means that these two angles are equal. Now we need one more angle, which is this angle and this angle. Thus, we have a case of angle, angle, side. The side is not between the angles. Now we proceed to find the unknown angle. We name these two angles theta because they are the same, they are given. Therefore, we have triangle ABE equals to 180 minus theta because they are supplementary angles. Similarly, the angle DCE is equal to 180 minus theta, again supplementary angles. Therefore, we can say that angle ABE is equal to angle DCE, since both of them are equal to 180 minus theta. Now we have also noticed that EAB is equal to EDC. And these are equal angles because they are base angles of the isosceles triangle EAD. Finally, we have the given side, which is EA equals to ED. Therefore, we conclude that triangle ABE is congruent to triangle DCE, and the reason is angle, angle, side. This concludes the proof.